What up?
Mhm.
All right, you ready?
Yes.
All right. So we'll do the same thing and we'll go through it together.
Okay.
Slowly rolls. Whatever. And hits another mass. Okay, go ahead. I'm going to add something, but just start thinking about it. So what do you think? In fact, I will always just, so you know, like we got two objects, we have to write the stuff down. Okay.
Yes.
So I started, you finish.
Okay. So final velocity. Okay. So you have the masses of both objects. The first locomotive. Okay. So the first one. Okay. So I'm one. Okay. Wait. Okay. So the initial velocity of the first locomotive is 4 meters per second.
What should I call that?
You should call that VI.
V1I. Just like before.
V1I equals 4 meters per second. And
So
then
is that okay? Did you get that moment of clarity there?
yeah.
I'm going to do the same exercise here. So this is what we did last time because you said VI, and I'll say, okay, fine. What do we call the second one now?
The second one. Wait, I'm sorry, it cut out. Do we need the wait? Do we need V1I or is it what?
Yeah, we need V1I. Sorry, I was saying this is exactly what happened last time where you said VI, and then I went through the process because now we don't know what to call the second one. It's not enough information in this variable. So that's why we have to say this.
Okay.
So yeah, keep going.
Okay. So the second locomotive is at rest, so the initial velocity of that one, so V2I would be 0 meters per second.
Great. Yeah.
And we're trying V1F and V2F.
Okay, fine. I'm going to stop you there. That's only for elastic. This is an inelastic collision.
Oh, okay.
But let me ask you why. Do you know why?
Because they stick together.
Yes, yes, yes. Drill that into your head. So the thing that we want to find, there's not two velocities anymore because they're one object.
Mm-hmm.
So there's just VF. You can just call it VF.
Oh, okay, because it moves together. Okay.
Good, good. Yes. This is the initial situation. Here's our guy. Here's our guy. Great. I don't even have to add anything else. This is what after it hits, that's what it is. 1, 2, right? But they're together. So they have the same velocity.
Okay.
They have to if they're stuck together. They better have the same velocity, or you know,
Mhm.
we're in a different universe or whatever. Like it's one object.
Yeah.
Okay, good, good, good. Keep that picture in mind. In fact, I want to do the math on here, but write that down if you need to on your test or whatever tomorrow or now, but use that picture if you need to convince yourself that this is true. So what do I do now?
Okay, so you need to find the final velocity. So, I think that you would use,
That's your hint.
velocity.
Whenever it's an inelastic collision, you always have to use this equation. There's no other choices.
Okay, so pi equals. Oh, okay. So then out of that,
Mhm.
you would use like the m1 v1 plus m2 v2. That one, right?
Yes, yes. Tell me exactly what to write down here.
Okay. So pi equals pi. So pf equals m1 plus. Wait, so
This,
if it's just one final velocity,
yes,
then what do you write?
this. That's what you write.
M1 plus m2. Oh, okay.
But you better make sure you understand that.
Yeah, that makes sense. Okay.
Okay, good, good, good. Because that's kind of some people,
Yeah.
it takes some time. Good, excellent. So what's the left-hand side equation? That is PF. That's what you said. Good. What is PI now? What's the left-hand side of conservation of momentum?
Okay, so pi initially is pi equals m1 v1 plus m2 v2.
Almost. I'm giving you a hard time here, but you said don't forget that
The
I.
initial, yes.
Good.
Okay,
Doesn't really
so
matter here. Good, excellent. Okay, so now what do I do?
wait, so that side would stay the same, correct? Because it's just the initial, right?
I'm not sure what you mean by that, but we have the equation we need.
Yeah, so like you know how for the f it's like originally it has the two final velocities, so you don't change anything for the initial side, right?
Yeah, this is yes
Okay.
or no. The answer to your question is yeah. You don't change anything.
Okay, so it stays the same. So it's m. Okay, so it's m
Oh, I see
one
what you're saying.
v one I.
It's the same as an elastic collision, that's what you're asking.
Yeah.
Yes, yes, yes. And then yes, this is what changes for the elastic versus inelastic, that right-hand
Okay.
side.
Because it stays together.
Yes, and that's the big difference there. But also, don't forget about kinetic energy, right? We can't use the equation here, but yes, this is a great insight you just got.
Okay.
If you can remember what you just learned and said out loud, and the fact that the kinetic energy is not conserved, then you win. Like you succeed. You got what he wants you to get. You win. Okay. So now what do I do?
Okay, so you want to find the final velocity, and that's on the right hand side of the equation. So you're gonna I it um by moving the m1 plus m2.
Yeah. Okay. Move it. Sure. How do I move it?
Um oh, okay, so you're gonna divide by m1 plus m2 on both sides.
I have to, right? If I'm multiplying, I have to divide to get rid of it. Right?
And then doesn't that cancel out the m on the other side?
Yes, that's why you do it.
Okay, so then you're left with v1i plus v2i equals vf.
Well, you forgot all your masses, but yes, kind of. This is what it is after you cancel. Oh, you're asking me if it's canceled on the left-hand side.
Yeah.
I thought you meant the right-hand side. No, because
Okay.
it's not. Okay, good. Does it make sense why it's not? It's a math question, algebra question, right?
Mm-hmm.
And you get why it's not?
Yeah.
Okay, good. So yeah, you did it. I mean, that's everything. Yeah, we got to plug it in, but the hard part is now done.
Okay. So you would get
I'll do it too.
100,000 kilograms
Yes.
times 4 meters per second plus 50,000 kilograms times 0 over 100,000 kilograms plus 50,000 kilograms.
What'd you get?
Let's see. I got 2.67 meters per second.
Nice. That's what I got. So yeah. So that it sounds like you're like 75, 80% of the way there. Just need to do a few more problems. If you have them, we'll definitely do some more right now. But if you have access to some, you should do some. Okay. Sorry, you said impulse and momentum, right? There's nothing else.
Yes.
And collisions, which is conservation of momentum, of course. So
Yes.
how's the impulse? We did two. Hopefully straightforward.
A little bit. We just briefly go over it, please.
Yes. Yeah, problem is always best. Okay. Where's an easy one? I'll just yeah, those are good ones. A baseball, a bat. With a force of 500 and is in contact. That doesn't make sense. 0.2. All right, let me not be that bad. Okay, So I want you to find the velocity
Okay.
of the baseball. So go ahead. In fact, I'll start what you always want to do. Oh, so we got here. Now you finish.
So your mass is 5 kilograms. You have a time which is 0.2 seconds, and you have a force of 500 newtons.
Great. Agree.
So you would
What are we trying
use
to
the equation P equals 4 times. Wait,
Sorry, is that what you said? Cut out a little bit.
yeah. So you try to find. Okay. And then if we're trying to find the velocity, would it make more sense to use the P equals mv?
So yes. Okay, fine. Let's go through it. Let's go through it. Sure. That would be the equation, right?
Mhm.
Okay. And then I'll solve for VF. Yes. But we don't know this PF. I don't know what final momentum is. They don't give us that.
Oh, okay. So it would just be the delta P force times time.
Impulse. Yeah.
Yeah,
The trick is
impulse.
if you see time, honestly, if you see time or force, but time is the clear giveaway. If you see time in your problem, you say impulse, 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 whatever. You know what I'm saying?
Okay.
If you see time, it's impulse. Okay. So
Okay, that
yeah.
makes more sense.
Okay, good.
So, okay, so then it's just 500 newtons times 0.2.
Sure. What is the left-hand side though? Now, if I was asking you for the change in momentum, yeah, sure, that's easy. That's done. But I'm not asking for the change in momentum. Remember, capital triangles change in momentum. We need the final velocity of the baseball. So to be clear, you're not wrong. This is obviously right, but that gives us, I mean, what is that? 100. So yeah, we know delta P equals 100, but we still don't have information about the velocity.
Oh, okay. So is this the PI equals PF?
That's
Or
conservation of momentum. And you just have to remember that's
oh,
your one. What is this thing? Remember the capital triangle, the delta? What does that mean?
it's the change.
Change. Good. Triangle, change. Okay, that's good. You got it. What's the math now? How do we denote a change in math?
Subtraction.
Yes. What do I subtract?
Okay, subtract.
Some final minus some initial. I don't really know what they are, but this is like
Okay.
good. Yeah, this is like the definition. Okay.
Okay.
So what do I do now?
Um. So. So it would be PF minus PI equals force times time.
Yes. I still don't have what I need though, right?
Yeah.
So what should I do?
Um.
What's the most basic equation for momentum?
P equals M times V.
Yeah. So how does that work here? What should I do?
Um,
Here, I'll start you off. What's the rest of it?
oh, MVF equals,
What is this thing?
oh wait. MVF.
Minus PI. I mean, I didn't change this yet, but what is that equal to? You don't need any notes. You don't need anything. All you need is this, what you said, and you know very well, right?
Okay.
If PF is equal to MVF, then what is PI equal to?
Uh-huh. Oh, MVI.
Yes.
Okay.
It's all right. And then I didn't do anything to the right-hand side. Now we can do what we had. We started with this, and you did that great. You got here. That's great. We still didn't have what we needed, but we know that momentum is equal to mass times velocity.
Mhm.
So now I have what I need, you know. So what do you think? And we're done. We did the hard part. Now we got to plug in numbers and get an answer.
Mhm.
The usual solve for whatever we want to. We have a hint though, because we know that this is 0, that initial velocity. We probably should have wrote that down in the beginning.
Oh, okay.
It's sitting, the keywords, you know, it's sitting on a T, but usually I think you might see where VI is not 0, but this is the standard.
So then you just,
Yes. So 20, I think.
okay, that makes more sense now.
Hopefully you're seeing that you're going to have to do this. Like that's on your equation sheet. And you remember that it's impulse. If you see time or force, but definitely if you see time, well, you got to use this equation. But don't forget, you gotta manipulate it. You gotta move it around.
Okay.
And just like this one, just don't try not to confuse when to use which, right? Because obviously, yeah, you got to manipulate that one. And that one's tough, right? Because it's M1V1 plus M1V2 with your
Yeah.
I's and your F's, you know. So that I guess what I'm trying to say is keep that in mind. That I mean, it might be one that's like you only have to use this equation, but don't count on it, you know.
Okay.
Okay, let's do another one of these. Okay, was at all right.
Okay, so um there are okay, so there's two objects. The first one, so M1 is 10 kilograms, and then M2 is 8 kilograms. And then
And what?
the one I is 5 meters per second. And then VTI is also 5.
Yeah, I didn't mean to make. So we don't get confused. Yes, good.
Okay, so okay, and then you have a final one. Sorry. V2, yeah. V2F
Good.
is 6.
Yes. Okay.
And then you don't have V2I
V1I.
or V2F.
I'm sorry. V1F. Right?
V1F. Okay, yeah.
Great. And that's what they want us to find. Yeah.
Mhm.
So I think we haven't used this yet. This is a good, that's why I did this one. If you see elastic collision, I would try to use, if you can remember to use this one, Ki equals Kf.
Okay.
This one always works. That's what we've been doing. And it will always work because momentum's always conserved. But I believe that he wants you to use this one.
Okay.
So, but it's no different. So please don't be discouraged. It's literally the same thing as that. But obviously, kinetic energy is a different equation than momentum, right?
Mhm.
But everything's the same. So see if you can do it using this one instead.
Okay. So we want to find the final. So
I'm going to write this down and you tell me if you see that, if you see this or not.
oh,
It's not the exact same as momentum, but it's basically the same, right?
mhm.
But instead I'm
Yeah.
using the equation for kinetic energy now. Okay, whatever, but it's the same concept. So finish it for me. What is the right hand side?
Um so would it be just 1/2 to f.
Sorry, I forgot my
Yeah.
subscripts here. There, that's right. But it should be M1, right?
Yeah, sorry. M1 V1F squared
Yes, good.
plus 1/2 M2 V2F squared.
Beautiful. And that's, I mean, the hard part's done. Again, now you have to solve for a variable, right? Which one? This one.
Mhm.
So that's a bunch of algebra. We'll do it, but clear and good, hopefully.
Mhm.
Okay, good. So I'm gonna start this on a new page, and I'll have you do this one. Got you. M1 V1I squared plus nope, V2I squared equals 1F M1 V1F squared. Okay, so how do I go about, what do I do?
Okay, so we're trying to find the final velocity for V1.
Yes.
Okay, so you're going to isolate the or you're going to move the 1/2 m to the 2f squared and move that part to the left side.
Yes, good. I would, you're 100% right. There's not really a correct step, but it's easier to say this first, right?
Mm-hmm.
You good with that?
Yeah.
Okay. So then what would my left-hand side be then?
Okay, so first you would have m1 v1I squared
Good.
plus m2 v2I squared
Yeah.
equals m1 v1f squared plus m2 v2f squared.
Yes.
Okay, so now you would subtract the m2 v2f squared and move that to the left side.
So then it looks like this. Is that right?
Yes.
Good. Okay. What's next?
Okay, so then after that, okay, so now you're going to okay, so you're going to divide by m1.
Yes. Good. So I'm gonna switch the sides here. I think you're good with that, right?
Mm-hmm.
Good. So you got this big old long thing. But I haven't done anything. This is just that divided by, right? Like just like you just said. So, and then one more step.
Okay, so you have to get rid of the square, so you square root both sides.
Both sides. Yes. And so it's basically the same again as the momentum. It's just more complicated, right?
Mhm.
That's why you don't do this if you don't have to. Like I said, I think you might want to if it's an elastic, and just do what you can. You know what I mean?
Okay.
So then plug it in. I'll do it too. We can compare. I gotta go back and look. 16. 8 times 25. It's 8 times 36. Okay. Great. That should make sense. Seems a little low, but it's also difficult with the squares to actually know. So that's what I got. I'm gonna double check though. 8 times 36. So yeah,
Yeah.
maybe. So you want to remember this page here.
Mhm.
I know it looks complicated, but just piece it apart. You know how to do this by now. You're good at this now. Breaking things apart and seeing what's what. Your process you got down. That's why we did that in memory. Write down what you got and then which equation. And again, you're going to have to solve for delta P, or you're going to have to figure out what PI is. It's not just PI. Yeah. M1 V1 plus M2 V2. Delta P, right, is ultimately MVF minus MVI. And go through the process, show the work for the impulse one, right? Yeah, right here in that second column, delta P is PF minus PI. And then you'll be good. If you can, I know it's a lot, but if you can remember that elastic versus inelastic collision, then you're master. And like I said, it seems like you're already 85% of the way there. And so you don't freak out, there's probably going to be a curve, because this is, people don't do well on this stuff. You know, it's hard, as you can see, it's tough. And so like you're going to do great. And yeah.
Thank you.
Do you want to talk about any of this? I didn't really cover the automobile safety. I mean, it's a bunch of, it's strange. But, maybe he's
Yeah,
got,
if we could just like briefly go over it, because it's an interesting section to be tested on.
yeah, it's kind of like he's got like a, engineering safety fetish or something. It's just like no math, and
Yeah.
it's just kind of weird. You're talking about the horn and the heads-up display.
Yeah.
um, all right. I mean, windshield wipers. All right. So let me actually give you some good information. If he's going to test you, there's probably keywords here. It's not just like, oh, windshield wipers, obviously, but like you want to think, if you can try to, when you think of windshield wipers, think of like visibility. That's your keyword. And maybe adverse weather conditions, turn signals, communicate intentions. Definitely don't remember these entire things. Just try to say turn signals, communicate intentions. You know what I mean? Like keywords for each one.
Mhm.
Horn, emotions. Don't even, I know it's a little more on some of these, but just keep it as simple as possible. One word for each,
Okay.
because there's a lot here, and it'd be weird. Like if if half the test is this, like I would expect 1 or 2 questions on this, I guess. Maybe it'll be a mix and match. You know what I mean?
Yeah.
Maybe the whole thing, like an infrared sensitive camera that scans in front of the vehicle, but okay, FLIR. We're looking infrared, and where you get everything on the page and just have to match it up. So yeah, he's definitely got a weird thing for this stuff, because like rare and very expensive as of today, like he's looking on Amazon for that stuff as he's building this worksheet. Just for comfort. Okay, seat shape design, trap you, but like trap you in a good way. Like if you get hit, then you're not screwed. Screwed. Headrests, cameras, lane departure warning. That's a weird one. Electronic system. Oh, like an autonomous vehicle, I guess, like a Tesla. Maybe. You get a little beep. Makes sense. Blind spot moderate monitoring. God, so pages of it too. Yeah, were you looking? I hopefully I helped you. I mean, like I said, this is way too much to remember, and like just try to attach one word. Nice nails, by the way.
Thank you.
Simple but classy at the end. I like it. So were you looking for something else on this? Like, because obviously you can read, and you know what I mean, but hopefully I gave you a good tip.
Yeah.
I guess. Okay. Yeah, and man, honestly, don't eat. How many are here? 1, 2, 3, 4, 5. Yeah, 11.
It's like 4 pages.
Yeah, 16 things. All right, so there's no way you're gonna have to write that stuff down. Just one word, and like it's got to be a mix and match. And there's no way he's putting all 16 on here.
Yeah, probably not.
Yeah, I hope not. All right. Well, again, good luck. I hope you do well. I'm sure you're gonna do great. So, yeah.
Okay. Thank you so much.
Of course. Take care.
Thank you. You too. Bye.